All right, how's everybody doing out there? Today we're going to chat about measuring earthquakes, right? I'm sure you've all heard of the Richter Scale. Maybe you've heard of the Mercalli Scale, right? Those are two different ways we measure earthquakes. Maybe you heard of a seismograph, right? The instrument that we use. Well, we're going to talk all about that today. And how do we measure earthquakes? Going to start out with just one of those, grab your attention type of clips. Check it out.
When we least expect it, when we're least prepared, disaster can strike. And few disasters are as unsettling as an earthquake.
So it's important to fight.
Every day, the Earth is shaken by hundreds of small earthquakes. Most go unnoticed. They usually occur along the boundaries of the thin plates that cover the Earth like an eggshell. Driven by the heat deep within the Earth's core, the plates grind against each other on long lines called faults. When the plates find their motion blocked, stress builds up. Finally, the fault gives way. The released energy races through the Earth in the form of seismic waves. For much of the world, the movement of plates like these is also an indispensable creative force. Earthquakes have been shaping landscapes for eons. It's only in the last few hundred years that civilization has gotten in the way. And when it does...
All right. So the other day we read an article on some earthquakes that happened in Long Island. Yeah, it is possible. Generally, you don't get the monsters here, right? We're not on a plate boundary. We talked about those plate boundaries a little while back. But certainly it can happen to us and has. All right, so let's be prepared just in case. Some of the headlines from Newsday after those earthquakes happened, right? Did you feel it? It's a good little catching newspaper earthquake. Rattled, right? What was that? Because let's face it, they're not as common here as they are in other cities located closer to a plate boundary. All right, this was a major one that happened in New Zealand. Check this out. The road was offset by about 30 feet, right? 10 meters, about 30 feet. You could see the road used to be connected here, and this whole area shifted on this transform boundary and moved the house 30 feet. Well, you could see the house was very, very damaged. It looks like it's going to have to be demolished and rebuilt, but that was obviously a major, major earthquake in New Zealand. Okay, so how do we describe an earthquake? Make sure you get this in your notes, folks. Violent shaking of the Earth's crust caused by the movement along faults or plate boundaries, of course. Most earthquakes occur when the stress builds up, and eventually the rock can't hold it back anymore, and it snaps. And you get what's called an elastic rebound, and that's what the shaking of the Earth actually is. So make sure you read that through. And, of course, we're going to talk about seismic waves as well. Okay. So there's some vocabulary on your next slide there, and I want to see if you could put it in the proper place based on the definitions there. You'll notice there's 4 boxes. You have to identify the features, write the description of each term in your notes. Shouldn't take you more than 3 minutes or so. Looks like this. And like I said, you have the vocabulary and descriptions on that previous slide here. All right, so hit pause, take a couple minutes, and figure out those terms. All right, so for your focus, hopefully you realize that's going to be that point deep beneath the Earth's surface where the actual cracking occurs. All right, the waves go out in all directions from the focus, right? The waves, I'm talking seismic waves here. The place on the surface directly above the focus is called the epicenter, and that's where we measure out from. It's probably the most common term you've heard. And of course, the closer you are to the epicenter, generally, the more shaking and damage you will find. Over here, the actual crack in a rock, right, that's called your fault. And these dashed lines here, right, those are your seismic waves. Like I said, they go out in all directions. And we'll study those in more detail a little later on. You have the P, the S, and of course, the surface waves. And you've all heard of aftershocks, right, all sorts of different energy coming out from, originating from the focal point. Okay, how will house 1 and 2 be affected? Well, ask yourself who's closer to the epicenter, right? Is it 1 or 2? And clearly 2 is closer, so it should shake a lot more. There are other variables, right? The land, for example. If you were on solid bedrock, you won't shake as much as somebody whose house is on loose sediment. Okay, so let's say both houses are the same distance from the epicenter. The person on solid bedrock will probably fare better because there's less shaking. But in this case, they're both on solid bedrock. It's just the difference is 2 is a lot closer. Well, that, of course, will play a role in the amount of damage you're going to get. So here's your seismic waves, right? Energy going out in all directions. That point there, remember, that's your focus, right? The point directly above the focus is your epicenter. Very nice. And of course, this here, the actual crack itself, right, that's your fault. So just a prettier way of looking at it. Here go the houses. You can see 2 is shaking a heck of a lot more. As a result, they're going to sustain a heck of a lot more damage. And there it is. House 2 is falling apart while house 1 stays intact, right? Distance from the epicenter plays a big role in how much damaging effects you will receive from the earthquake. All right, so how do we measure earthquakes? Read this through, right? Talking about a seismograph. That's the instrument, of course, that measures the shaking, and then the piece of paper, they call that the seismogram. And you can see different waves here. The first wave to arrive is always the P wave. We'll talk about that. The second wave, right, the secondary waves, you can see a second series of vibrations there. And, of course, after that, even other types of waves there. But get those down. There's your seismograph, the actual instrument. And the seismogram, the piece of paper that the waves are recorded on. Okay? Those giant drums there, they spin constantly, very slowly. And every so often you have to change out, right? You run out of paper. But because they spin constantly, they will record exactly when the shaking starts. And then we'll analyze these waves. You'll be able to tell how big the quake is. Be able to tell how far away the epicenter is. A lot of information is obtained from what looks like scribbling, but that's actual a very important data being recorded. Okay. Intensity, take a look. We've all heard of the Richter Scale. And you can see here it kind of goes in an exponential increase there. Each power on the Richter scale is 10 times more. So for example, in the corner here, here's a 5. A 6 is 10 times stronger than a 5, and then 10 times 10 is 100. A 7 is 100 times stronger than a 5. So even though it's only 2 numbers on the Richter scale, it's a big, big difference. Okay? Let me make sure you read that through there. Richter scale, right? The scale that measures the total amount of energy released by an earthquake. It is between 1 and 10, although there is no limit to the amount of energy, right? You can be certainly off the scale there, right? There's no limit to how strong an earthquake can be. All right. Strongest earthquake ever recorded, to my knowledge, unless there's another one out there, but it was about a 9.5 in Chile, and it literally lifted part of the Earth's crust by like 30 feet high and thrust it out of the ocean. Unfortunately, of course, many people were killed in that scenario, but it was absolutely devastating. They found fish on the second story of buildings, right? That's how, the tsunami that was triggered by this, it was truly unbelievable. So how do we measure the amount of damage? This is a different type of scale, right? The Richter was power, and this is called the Mercalli Scale, and that tells us about the amount of damage. And same thing, it's a 1 to 10, but now it's the type of damage that you can expect. It cues in rescue crews, right? If they know there was a 5 or 6 or 7, they know what they're in for when they're heading out to save lives. Okay? I'm sorry, this one is from 1 to 12. My apologies. Here's a little clip from a movie. I don't know if anybody's seen Ocean's 11, Ocean's 12. This is a clip from there where they talk about earthquakes. Check it out.
That's a 5.6. If you don't think a 5.6 is possible, or even likely, then quite frankly, you don't know much about the Billups-Mancini report, specifically the section on the Mojave Block. I know what you're hoping. It'll just be a blind thrust fault.
We haven't even opened yet.
What are all those people downstairs?
That's a soft open.
It's like an out-of-town
What do you think?
preview.
You just come in here and tell me to close my hotel? I'm not going to close my hotel.
Sir, if you'll just let me come in with my team and our gear for a few days,
No.
I can prove what I'm saying.
Hey, there is no way we are exposing our exclusive clientele to a bunch of...
Scientists? We wouldn't want that, would we? Let's just hope for the best, shall we? That should be enough. Take this. It's a standard torsion seismograph. If there's a foreshock, it will register, and you just might have time to evacuate.
I don't want this thing on my desk.
Well, sir, let me tell you what you don't want. Your hotel on the cover of Time magazine, in a twisted heap of steel and glass. You and your customers are underneath it. Headline reads, "Who's to blame?" That's what you don't want.
Okay. Put an evacuation plan on paper.
Will do, sir. Consider it done.
I do thank you for your time.
If you want to really put yourself to good use, why don't you hit the tables?
Oh, I don't gamble, sir. Neither should you, not with people's lives.
I'll screen the meetings more carefully next time.
Sorry.
And now we have a camera in the bank.
All right, there was your seismograph. Now, of course, in a movie that was planted there for other reasons. But interesting scene. They're in Las Vegas, Nevada, right by a major fault zone. So, of course, that they use that fear to try to do a bank robbery type job. But anyways, so you got a couple summary questions. How do we measure earthquakes? How is the Richter scale different from the Mercalli scale? Make sure you get those in there. And as always, some Regents questions as well. All right, so go through that. Make sure your notes are in there. And I'll meet you back in a meet.